who is the inventor of the non-parametric statistical method. And what we learned before in common is that there's an assumption to the distribution, and there's also the parameter for the sample. Like we assume that the distribution of the sample is same as the distribution of the population, like the uniform distribution, normal distribution, or exponential distribution. For example, for the normal distribution, we all assume that the mean of the sample is equals to the mean of the population which the sample derived from. However, we do not know about the shape of the distribution. And then we need to use the non-parametric inference or the distribution-free test. And the condition that we can use this method is that we need to ensure that the population is month-shaped, continuous, and also independent, as shown on the diagram on the middle of this slide. And why it makes sense? Because it may based not on the actual magnitude of the value. Instead, it's based on the rank. And it is the Frank Wellcosen who is the inventor of the Wellcosen sign rank test and also the Wellcosen rank sum test. On the 6th of December of 1945, he published it in Individual Comparisons by Ranking Methods, and in this paper, he introduced two ranking methods for the non-parametric, the two methods for the non-parametric statistical test. And here is the example. For example, we have a company who gives them invent the pain relief drug, and after some improvements for the drug 1, they invented the drug 2, and they want to test whether the drug 2 is more effective than the drug 1, which is that the drug 2 gives a longer pain relief than drug 1. And then we have two hypotheses. The first one is the null hypothesis, and also the hypothesis that we test in this methods. It is the time or the say before and after, which means that the effectiveness of the drug 2 is equals to the effectiveness of the drug 1. And another hypothesis is that the time afterward have increased, which is the drug 2 is more effective. And then we will come to the most important step of this method, which is rank the magnitude of the differences. And we should ignore the sign, like the positive or negative of the magnitude. We should only rank the magnitude of the differences. And here the before is the drug 1 and after is the drug 2. And then we need to calculate the sum of the ranking. For the positive, in this case, is 16, and the negative is 12. And what we need to do is to use the minimum of the sum, which is 12 in this case. And then we can look up the critical value in the statistical value, a table, which is 3 in this for this test. And then we will come to the analysis of the test. As the 12 is higher or greater than 3, which means that the test statistics is bigger than the critical value. And as we are testing the null hypothesis, it means that there is no sufficient evidence to reject the null hypothesis. And then we can we can know that there is insufficient evidence to suggest that the drug 2 gives longer pain relief, and it is not that effective than the it is not more effective than the drug 1. In conclusion, I think that the most significant of the invention of the Wilcoxon is that he makes the statistical methods more robust and applicable to a wider range of real-world problems. Because as we said before, we do not need to know the distribution of the whole population, and it will apply for the wider range of the problems. Like if you want to know whether there's a better like the service rating after some improvement. And then what you need to do is that you can compare the before and uh after rating, and then you can just know whether it improves. And this is the statisticians and his methods that I want to introduce today. Thank you.